Lesson 6.1, Graphing Sine, Cosine, and Tangent Functions. So in this chapter we are continuing our look with trigonometric functions, but we are actually looking at them more like functions. So in the last chapter, even though we talked about trig functions, we were really looking more at how to evaluate the trig functions. If we put in a certain number for the angle, then what is the sine of that angle or the cosine of that angle? Or vice versa, if we know that the sine or the cosine is supposed to be a certain answer, then how do we figure out the angle that goes along with that? Then how does that all relate to triangles? So that was last chapter. In this chapter, we are still using trig, but we're thinking more in terms of it being an actual function, like we've seen with quadratic functions and polynomial functions. And so part of that is looking at what the graph would look like if we graphed it on a coordinate plane. So let's take a look at the graph of y equals the sine of x. Now we're going to use the common angle table that we filled out in the last chapter. But since that was part of your last booklet, I have provided it for you on the back of your notes page in this new booklet. So you have all of the values already there that we're going to be using. Now when we graph the sine function, one of the things we have to keep in mind is how we're actually going to set up the graph, because it's a little bit different than what we normally do when we set up the axes on a graph. The first thing we need to realize is that the x-axis is going to represent the radian angle measures. So that's one key difference. We need to be using the radian measures. You will sometimes see this done with degrees, but it's more complicated when it's actually done with degrees. So we're going to be using the radian measures for our x-axis. And then our y-axis obviously will represent the trig values that we get when we take the sine of that angle, the cosine of that angle, and so on. So here's what our table looks like. And so what we're talking about here is using this row as our x values. And then for the sine, we'll be using this row for our y values. Okay, so these are the points that we're going to be plotting. So let's take a look. If we set up our x-axis, and I would recommend on your paper that you actually turn it sideways so it gives you a little bit more room on the x-axis instead of the y-axis. If we take a look at our x-axis and we go back to our table, our range of x values goes from 0 up to a 2 pi. And so that's what we need to consider when we're setting this up. So because we have 12 boxes here, in our positive x-axis, we can go by a pi over 6 for each line. Now it gets a little crowded if we actually record or label pi over 6 for everything, so let's just label some key points. So if our first line is pi over 6, then that would mean our second line would be 2 pi over 6 or pi over 3. And then our third line would actually be 3 pi over 6 or pi over 2. So let's just go every 3 boxes and label by pi over 2's. So here's another 1, 2, 3 boxes, and another pi over 2 would put us at pi. Then if we go another 3 boxes, another pi over 2 would be 3 pi over 2. And then finally, 3 more boxes would put us at 2 pi. Okay? So we're actually counting by pi over 6, but we're only labeling sporadically within that so it doesn't get quite so crowded. Now, what about for y values? If we go back and take a look at our y values, our biggest y value is a positive 1. And our smallest y value is a negative 1. And so with that in mind, we don't really want to just go from positive 1 to negative 1 like this, because that's going to really crunch everything together and make it hard to see. So I would suggest that you maybe go, let's say 4 boxes up and down and label that positive 1 and negative 1. That just gives us a little bit more room to graph what's going on and to get our points in there without everything getting so crowded. All right, so let's get started here. So when I have 0 for x, I have 0 for y. So my first point will be here at 0, 0. When I have pi over 6 for x, then my y is 1/2. So remember, pi over 6 is just one box over, and 1/2 now is going to be up 2 boxes. Excuse me. If we continue, pi over 4 is going to be the square root of 2 over 2. Now, pi over 4 is not a particularly easy tick mark here based on the way we've done things. So let's just skip that for a second and let's go to pi over 3. Pi over 3 is the square root of 3 over 2. If you plug that into your calculator, that ends up being about a 0.866. And pi over 3 is my next tick mark, because remember that's 2 pi over 6's. So pi over 3 is going to be at about 0.866. So that's going to be a little bit more than my 0.75 and put me at a point maybe right about in there. Then if we go to our next angle measure, that's pi over 2. That's when we get a y of 1. And so we get a point right about there. Okay, now when I go to my next x value, which is 2 pi over 3, notice that I'm coming back down now because I've got the square root of 3 over 2 again. So at 2 pi over 3, I'm back here at that 0.866 value that I had at pi over 3. And then when we go to 5 pi over 6, because again 3 pi over 4 is not going to be real easy with my tick marks, I'm back down to 1/2. So 5 pi over 6, 1/2, about right there. When I get to pi, my y value is 0. So down here at pi, I drop all the way down here to our x-axis. Okay, right about there. Okay, then continuing, 7 pi over 6 puts us at a negative 1/2. So now we're dropping down below our y-axis and putting a point right there. We're going to skip the 5 pi over 4 and go to 4 pi over 3, which puts us at negative square root of 3 over 2, so a negative 0.866. That's going to be right about there. And then our 3 pi over 2 puts us at negative 1, which puts us right in there. Okay, then in our final quadrant, we've got 5 pi over 3, which gives us the negative square root of 3 over 2 again. So another point right in there. At 11 pi over 6, we've got negative 1/2 again. So that's going to put us right about there. And finally, when we get back to 2 pi, we're right back to 0. So that puts us right about there. So what you see happening here is a curve that starts at 0, 0, curves its way up until it hits 1, and then curves its way back down, crossing over to the negative side, and then curving back up to end up back at the x-axis. Okay, so that's what we get simply by going through and plotting our x values as the radians and our y values as the sine of those angles. Now, here's what I want you to do for next class. There's two things. A, I want you to continue, here we go. I want you to continue the sine graph for negative x values. Okay, so we've already got a good start on the sine graph with our positive x values, but now I want you to think about what would happen if we went clockwise around the unit circle. So if we went with negative angle measures and finish up the sine graph for the left side of the graph. And then part B is I want you to use a different color, and on the same graph I want you to graph the cosine function. And again, for both positive and negative x's. Okay, so that when you come in to class tomorrow, you are going to have a complete sine graph and a complete cosine graph that entirely fits your graph paper. And that's going to help us with our lesson in class tomorrow. Okay, so you don't need to change the x or y axes. They're already set up the way we need them to. All you need to do is think about how would the x values continue on the sine function and graph that, and then go through the same process and graph both the positive and negative x's for the cosine function. Come to class tomorrow with both of those graphs ready to go so we can use them in our lesson. And we will see you then.